All right, well, in chapter 4.1, we started talking about lines and linear models. And in section 4.2, we're going to talk some more about lines. We're just going to go a little farther with it. So the one part of of lines that we're going to focus on in this section is slope. Now, many of you may remember slope as rise over run. A lot of people remember rise over run, but what does that mean exactly? Well, I've written this same ratio in two different ways here that might help make it a little more make a little more sense. So slope is also the ratio of vertical change divided by horizontal change. So let's look at this graph here. This is from the last lesson. You might recognize it. So what that means is I'm going to choose 2 points, this and this point here. I'm going to choose these 2 points. And what I'm going to do is figure out the slope by looking at the vertical change and dividing it by the horizontal change. So I'm going to start on the left-hand dot. And I'm going to look and see between these 2 dots as I go from left to right here. This one goes, I have to go down 2 spots. So my vertical change is going to be -2. And now my horizontal change is just 1. So we would say that my slope is -2 over 1, or just -2. That's the vertical change over the horizontal change. Always as you move from left to right, you count how many up or down you need to go. If you go down, it's negative. If you go up, it's positive. And then you count how many you have to go to the right to get to that next point. And also recall in this chapter, we're looking at the vertical and horizontal as the input and output. So for example, so what that means, remember that the horizontal axis is the input and the vertical axis is the output. So we could look at this as the change in output was between 3 and 1. Between this 3 here and this 1 here, that was the change in output. So that's 2. And my change in input, I went over to 1 more. So that's what it is on a graph, a slope. And now we're going to look at what it means mathematically. So I've taken the coordinates of 2 points off of that line we just looked at there. And we're going to pretend we never saw that line. But we already know what the answer should be, so hopefully we'll be able to tell if we're right when we're done. So here's 2 points off that line, and there's a formula here that will help us calculate that slope. You may remember this same formula as the slope formula, where they use the letter m for slope, and m is often used for slope. So what this means is we have 2 points, and we're going to label one of them point 1 and one of them point 2. So let's say this is point 1, this is point 2. That means that this is x1, comma y1. This is x2, comma y2. And so we're going to plug those values into this formula. We have -3 minus 5 on top. And we have 4 minus 0 on the bottom. So what that gives us is -3 plus -5. That is -8 on top. The bottom, 4 minus nothing, is 4. So I have -8 over 4. Now all I have to do is simplify that, and I see if I cancel a 4 out of the top and the bottom, I get that same slope of -2. So these 2 points weren't next to each other on that graph, but it still gave me that slope of -2. -2 changes, the y changes by -2 for every 1 change in x. That's what that means. Y over x, change in y over change in x. Okay, let's look at this slope from one other angle here. So this is a word problem. I made it up. Okay, it's the same idea as what you're going to be doing in this lesson in just a few minutes here, but I figured I'd make up a different example to kind of show you how to handle these. So what we are supposed to do here is to find the slope of, or the rate of change, because slope and rate of change kind of mean the same thing, of the growth of this house plant. And before, on the previous slide, we were given the coordinates of 2 points, but here we're just given a bunch of words and numbers and sentences. So we have to kind of turn these numbers into points so that we can plug them into our slope formula. And here's what I mean. So x's are kind of our inputs and y's are our outputs. And we see that we have 2 units here, days and inches. Days and inches. And generally, when you have time, like days or hours or years or minutes, as one of your units, that's going to be your input. In other words, something is changing over time, and so your input is a number of units of time, and the output is, well, how much did it change in that time? So my days are going to be my x values, and my inches are going to be my y values. So this means this problem gives me 2 points, 3, 4.5, and 7, 7.5. So these are my 2 points. So now I just need to plug them into the slope formula. So that's 7.5 minus 4.5 over 7 minus 3. And that's going to be 3 over 4. So my slope is 3 over 4. And so I'm going to be asked now for units on this slope. It's like, well, the slope is 3/4. 3/4 what? And so the way we know the units is we look at the numerator value in the unit. And the numerator unit in this case is inches. And my denominator unit is days. And so that right there tells me everything I need to know. This is 3/4 of an inch per day. It's always the y per x, or top per the bottom. So if inches are on top and days on the bottom, I get 3/4 of an inch per day. So let me just highlight something here. Now, that last slope we calculated with the graph, we got a negative slope. And that line, if I were to sketch it down here, went something like this. Now, this graph over here has a positive slope. If I were to graph the plant growth, it would have a positive slope. So what that means, right? So this means that the change in x is positive and the change in y also is positive. They're both positive. So that means as x gets bigger, y gets bigger. So this is going to look something like that. So an uphill graph is going to have a positive slope, and a downhill graph is going to have a negative slope. So that brings us finally, at long last, to the problem in our book. And here it is. I've copied it into this video for your convenience. And we're talking about the consumption of milk and soft drinks by people in the United States. And what we already know, what they've already researched and found out for us, is the average annual consumption per person of each of these beverages. So here it says in 1950, each person in the U.S. consumed 36.4 gallons of milk. In 2000, people consumed 22.6 gallons of milk. So here we have two pairs of values, right? We have a time value in 1950 and then an output value, gallons of milk. We have another time value in 2000, another output value, 22.6. And so now we go back to soft drinks and we have another time value and we have a number of gallons. And we have another time value and we have another number of gallons. So so these are two different problems here. So you're going to find a slope for milk and you're going to find a slope for soft drinks. And you're going to need to use this formula to get there based on all these numbers and words in that paragraph up there, much like we did with the house plant.